Good morning, everyone.
Good morning, sir.
So I hope you have installed NLTK. Am I audible to everyone?
Yes, sir.
Okay. So NLTK stands for Natural Language Toolkit. So how we can use the language to do classification or doing analysis. So that is what this chapter is about. Now in NLTK, there are different things that we can do. That is what I'm going to tell you today. And there are languages available in which you can do analysis: English, any other foreign language, Chinese, even local languages in India. We have so many instances where this thing exists. Okay, language translation, classification, multi-class, multi-label, all these things are possible by using the concept of text analytics. So the list of things that we are going to learn today. So I'll just write those things first. So we have already seen the concept of tokenization. So what we saw yesterday was word tokenization. So today we are going to see something called as sentence tokenization. So we'll use both the word tokenization and the sentence tokenization using NLTK. After that, we are going to see something called as the concept of stop words. Before that, we also see dealing with special words that include, I won't say words, dealing with special formats like full stop and apostrophe. Okay, apostrophe means I can have can't, don't. So whenever you have these kind of text in a document, how can we extract those kind of sentence so that there is no, you don't lose that information. Okay, so that is dealing with special formats. Now in a dot, I mean words like doctor, full stop, Mr. full stop. So the full stop should not be treated as a end of sentence, but it should be treated as a part of the word. So how do you deal with these kind of things? Then we have stop words. So stop words means words that do not have much meaning. I will say do not have much weightage. So if I have to find out what is the influence of a given word, so I want to first remove the stop words. For example, I want to find out what is the influence of the word called, let's say, language in a given text. Okay, so I can write Sanskrit is a powerful language. Okay, it is the language of the computers. Let's say I have a sentence like this. Now I want to find out what is the influence of the word language in this given sentence. So first what I will do is remove all the stop words that does not contribute to my weightage. So my stop words will be all the words which do not give any meaning. So is will go out of the sentence. It is the, it does not have any meaning. Of and the, this goes out. So what I'm left with, only the keywords, which is Sanskrit, powerful language, language computers. So this is how we deal with text analytics when we are doing any analysis where I want to find the weightage of certain word or words. I will do something called stop words. Is this clear to everyone?
Yes, sir.
Okay. Next, after stop words, we have something called bag of words. So bag of words means that I want to find out the count of the words, how many words are there in a given text. So count. So let's say that let's say the word is, okay, let's look at the same sentence. Sanskrit, powerful language. So here I can say that Sanskrit occurs one time, powerful occurs one time, language occurs two times, computers occur one time. So basically it is counting how many words are there in a given text. Okay. So more the count generally denotes more influence. Okay. Then we have something called lemmatization or lemma. So lemma, or we can also call this as lemmatization. So lemmatization means that what is the meaning or what are the other words for a given word. Okay. So the dictionary meaning. So let's say that I have a word called program. So what are the other words that denotes the word program? I can have, let's say, a word called agenda, or let's say program also means schedule. Then appointment, etc., etc. So all these things mean that it is a program. Actually, the program spelling should be ME. Okay, so how do you get the lemma of a given word? And this can be useful when you are doing text analytics. So that is called lemma or lemmatization. Then we have something called as pause tagging. Pause tagging means part of speech. So in a given sentence, we have nouns, pronouns, adverb, verb, adjective, conjunction, conjunction. Okay. So how do you identify all these different types of parts of speech in a given sentence? So that is done using a technique called as POS tagging or pause tagging. Now there are instances when we want to extract all the names from a given sentence. Okay, let's say names of countries. So how do you know that this particular word is a country name? What is the hint that I gave you yesterday that this is a noun?
First letter capital.
First letter capital, right? So whenever, because that is how nouns are identified. Whenever you have a capital letter, the first letter of, the first letter of a word generally indicates that it is a noun. Okay, so we generally write, let's say, the word like this. or no, it could be, let's say, so always the first letter indicated in uppercase. So that indicates that it is a noun. So how do you identify the noun? How do you identify an action? Action is called verb. So what are the action verbs, words that I have in my sentence? What are the adverbs? What are the adjectives? How does a word get described? Those things are known as the pause tagging. So we'll see how to get those information. Then we have something called a very powerful technique called n-grams. So gramming means grouping of words. Okay, so grouping of words are very powerful when we want to identify whether a given sentence has a given positive sentiment or a negative sentiment. Okay, now let us say I give a word like beautiful. Now, is this a positive word or a negative word?
Positive.
This is a positive word. Now, if I put not beautiful in front of it, now is it a positive word or a negative word?
Negative.
This becomes negative. Okay. So if I have a sentence which contains the word beautiful, so how do I know whether it is a positive sentiment or a negative sentiment, or whether it says positive, good thing or bad things or not good thing? So I can use the concept of gramming. So I'll group the words in 1, 2, 3, or 4 groups of words. Okay, for example, I have a word called beautiful. So that will become 1 gram. Not beautiful will become 2 grams. So let me put it in brackets. Then I'll have one more word which says is not beautiful. Okay, so I'm going to group them in 1, 2, 3, 4, 5, whatever number you want, but generally we don't go beyond 4, or 3 is the maximum that we can have, but sometimes 4 is also allowed. You can go till 4. So this is how you group the words for your analysis. We'll see how to do all these things when we go to this topic of n-grams. Is this clear?
Yes.
Okay. Then after that, we have word similarity. So how two words are similar to each other? So for example, if I have 2 words, let's say cow and let's say cat. So how similar are these 2 words? Let's say I have a word called paper and let's say car. So are these words similar or are they dissimilar? How much are they in terms of similarity? So it ranges between 0 to 1. So it's a probability. So this is used again when we want to do any kind of recommendation of products, any kind of recommendation based on one word. So this is useful there. So this is done using the concept of similarity between 2 words. And what is the next one that we have? Tokenization, special formats, stopwords, backwards, lemma, pause tagging, and word. Yeah, I think, yeah, that's all. Okay, so this is the list of topics that we are going to cover today. Have you all installed NLTK? I told you yesterday to download the packages, the corpus, everything done? Okay. So let's import the library, NLTK library. So the first thing that we'll do is tokenization. So we have two types of tokenization. One is sentence tokenization and the other one is word tokenization. So we have already seen word tokenization, but let's do this again. So I have a sentence, let's say S1. There are 7 days in a week. Sunday is the first day. And let's say Saturday is the last day. Okay. So here I have 3 sentences. There are 7 days in a week. That is my first sentence. Second sentence is Sunday is the first day. And the last sentence is Saturday is the last day. Now, a sentence is separated from each other. 2 sentences are separated from each other by the full stop. So that is why I have 3 sentences in this particular text. Now we are going to extract all the words and also the 3 sentences. Okay, so first we'll do the word tokenization. So NLTK dot word underscore tokenize. Okay, so this is the name of the function. NLTK word underscore tokenize. And what do you want to tokenize? I want to tokenize the text S1. And now you will see that it breaks the sentence into individual words. So there are 7 days in a week, full stop. Sunday is the first day, full stop. Saturday is the first day. Clear? Now we'll see what is a sentence tokenizer. So NLTK dot sent underscore tokenize S1. And now see the difference between the two. So sentence tokenizer is going to split the text based on the full stop. So now we have 3 sentences in my text. हो गया? Clear?
Yes, sir.
Okay. Next, we will see what are the special formats like abbreviations and apostrophe. So let us say that I have a sentence that contains abbreviations. So is my NLTK smart enough to split the word into split the sentence into words, or does it recognize the abbreviation also as a full stop? So let's take a sentence S2. So let's say this is Dr. He's a famous surgeon. Okay, so here I have three sentences. So the first sentence has a full stop. The second sentence is a sentence which does not have any abbreviations. The third sentence has an abbreviation called Mr. Okay, so we want to ensure that the abbreviation is treated as an abbreviation and not as a sentence termination. So let's do NLTK dot sentence tokenize and S2. So now you can see here that the abbreviation is treated as an abbreviation and not as a sentence terminator. And you can also use the NLTK dot word tokenize. And now you can see that even the word tokenize works properly, where the doctor, the abbreviation is treated as a separate word. Is this clear? Any questions from anyone? Now we'll see how to split the apostrophe. Apostrophe is the words like can't, don't, wherever we use the shortcuts. So can't means it's a short form for cannot. Doesn't means it's a short form for does not. So let us create one sentence and see if the splitting happens properly or not. So let's say that I have a sentence like this. I can't do this. It's too complicated. It doesn't interest me. Okay, so let us say I have a sentence like this. So I can't do this. It's too complicated. It doesn't interest me. It's not my area. So that's a very colloquial way of saying not, so ain't. Now, if I use the sentence tokenizer, NLTK dot sentence tokenize and S3. Okay, so sentence tokenizer works properly. Now let us see whether the word tokenizer works properly or not. So I'll write NLTK dot word tokenize and S3. Now see what happens. So it is splitting when you have an apostrophe. So you're not getting the full word. So in the first one, it says I, which is fine, then CA, and then N and T are separate. So it is not taking the abbreviated word as a single word, but it is splitting them into two separate words. So result not as expected. Are you getting this same result, or whatever sentence you have put? Are you getting that? Okay, so now we cannot use the word tokenizer by using this technique of NLTK. So we need to do a small change to our routine. And that is done by using something called as a regular expression tokenizer. So to fix, so we will use regular expression tokenizer. So we have already seen the regular expression. So what regular expression does is it is going to find the patterns. So here first we are going to identify the pattern and then pass that pattern to my string. Okay, so here we have a function from NLTK dot tokenize import regex tokenizer. Okay. So first define the tokenizer. So I'll say token equals reg expression tokenizer. Now, what is the pattern that I want to find? So the pattern is any word, anything which is a character followed by an apostrophe. And then one or more instances of that. It could be one or more, or it could be zero or more. So that depends upon your sentence. So let us say that I'm defining the token as the character followed by a single apostrophe and then one or more instances. Sorry, this is not the token. This is the pattern. And then I will use pattern dot tokenize and S3. And now you will see that I'm getting the correct output by using the pattern that I have defined. Finished? Okay. Tejas and Yash done?
Yes, sir.
Okay. So next we'll go to the third one. Third one is stop words. So stop words means removing all the words that do not contribute much as part of the text analysis. Okay. Let me just. This is the first section. Okay. Now, how does stop words work? Let me just give you a quick introduction. So there is a library inside NLTK that contains a set of stop words. Just give me 1 minute. So we have a set, and in this set, there are words which are already predefined. So predefined words. So there can be words like is, not, in, of, or, does. There can be lots of things which are defined. So this is what you installed yesterday in the NLTK package. Remember, nltk.download, it is going to install a lot of packages, which is called corpus. So one of the corpus that gets installed is the NLTK stop words. So it has a list of, a set of words which are already predefined as stop words. Now you can also add your own set of words. It can be customizable. So I can write as custom stop words. Okay, let us say that you are dealing with some kind of text written by Indian audience. Now, generally, we use a lot of Hindi words or any local language mixed with English. Okay, so there can be words like, let's say, jugaad. And you can have a lot of the colloquial use of words. Okay, so I want to remove all these words from here and make my text in a clean form. So I can add all these words to my existing set of stop words. Okay, for example, paisa. Okay, so whatever the words that you can think of, which are not going to give any meaning to the sentence, I can put them into stop words. And then once my sentence is ready, I'm going to pass this sentence through the set of stop words, remove the stop words, and I get the formatted sentence. So the formatted sentence will not have any stop words. So this is the cycle. Okay, so first define the stop words, add the custom stop words if required, create the sentence, pass the sentence through the stop words, format the sentence, which will not have the stop words. So let's see how to do this. So we have to first import the library, and that is from nltk.corpus import stop words. Okay, now what are the predefined stop words? So I can write stop words equals a set of stop words dot words. Now this takes one parameter, and that is for which language I want the stop words. So you can write here predefined set of stop words for English language. So here I will write the parameter as English. Okay, so now if you print it, print stop words. So let's print the first 20 stop words. Oh, this is a set, no? Okay. Okay, so now if you just print it out, you will see that these are the list of stop words which are defined. So you, am, wouldn't, her, out, o. So it has created a couple of words, not a whole lot. Now we can customize the list of stop words. Clear? So I can write here, add new words to the stop words set. Now, when you are adding the new words to the set, it is only going to reflect in the current environment. It does not overwrite the predefined set. Okay. So it is valid only as long as you have this program running. Once you exit, the stop words that you added will not be applicable. So I want to add some new words. So I can write stop underscore words dot append. Sorry, not append, dot update. Okay, now in a set format, you specify the list of words that you want to update. Okay, so now let's put some words. Let's say I want to put this word called rupee, paisa, jugaad, and let's say gaadi. Okay, so these are typical Hindi words that we use. Now let me print the stop words. So now you should see all these 4 words somewhere in the set. Okay. So you just have to go through it. So here you can see the word that I've added, gaadi, is here. And then the other words like jugaad, that is here. Then similarly, you should see rupee and paise. So it has to be somewhere in this set. You see, paisa is here. Is this clear to everyone? Okay. So now we have defined our set of stop words. Now let's form a sentence. So this car, this is a luxury car that costs a lot of paisa. I have made some jugaad to get this in quick time. A friend of mine has arranged the paisa for me. Okay, so let us say I have a sentence like this. Now I need to get rid of all the stop words and take only the relevant words which make some sense. So let's see how to do it. So I'm going to first create a remove stop words from the sentence. Okay, so I'll create filtered S4 equals an empty list. Now, first I'll show you the long method, then you can convert this into a list comprehension. So for every word in S4, if the word is not in the stop words, okay, so if the word is not present in the stop word, you put that into the filtered word. Okay, so now let us see what is my filtered word looks like. So print filtered underscore S4. Okay, can anyone tell me what is the mistake that I have done here? Why am I getting an output like this? There is one step which I have missed.
Underscore?
No, I said I have to remove the stop words. Okay, so that means I have to first get the tokens. So NLTK dot word tokenize of S4. So token S4, and here it should be for W in token underscore S4. And now see. Now in this, I also have a full stop, which is this period here. So I can put that also in my stop words. So here I can put the dot, then run this again. Now see, and now I can write dot join filtered underscore S4. And now see the difference between the existing text and the filtered text. So luxury car costs lot, made, get quick time, friend mine arranged. and look at the original text. Is this clear to everyone?
Yes, sir.
So this is known as the stop words. Okay. So next we'll go to the fourth one. Fourth one is tokenization, dealing, format, stop words, and back of words. We will come to back of words in the end. Okay, let's finish back of words also. Bag of words actually is very easy. It is simply counting the number of instances that we have of a certain word. Okay, so can you do this assignment? Bag of words is count the number of occurrences of a word in a text. This is called bag of words. So let me give you an example. I have S4. Okay, let's take S5. So S5 equals Python is a reptile, is a snake. Python is a programming language. I like Python. Python is easy to use. I have seen a Python. Okay, so let us say that I have a sentence like this. So do this exercise. Let me see if you can, it's very simple. Count the number of occurrences of the word in the text. So the assignment is remove the stop words. That is the first one. And the second one is count the occurrences of each word. Store the result in a dictionary. So what you're going to do now is nothing but the bag of words format. So remove the stop words, count the occurrences of each word, and store the result in a dictionary. So do this assignment and then let me know. Then we'll go to the next part. Have we finished? Ankita, Yash, Tejas. Have you done the stop words?
Yes, sir.
Yes.
Okay, so let's do this one by one. So how to remove the stop words? So use the same technique that we used at the top. So filtered equals. So instead of writing it in 3 different lines, I can use the concept of list comprehension. Okay, you know what is list comprehension, isn't it?
Yes.
For every word in, so first we have to do the tokenization. So tokenization equals NLTK dot word underscore tokenize and S5. So just ensure that you are getting the output properly. Okay, so this is the list of tokens. So here I can write for every T in tokens, and then give the condition if the token is not in stop words, then return the value for T. Okay, and this becomes the list of filters. So if you look at filters, so now this is the list of words. So now I can write S5 filter equals dot join filter. Now print S5 underscore filtered words. Okay. Now we have to count the number of occurrences of each of these words. Now, once again, we will do tokenization. So token equals NLTK dot word underscore tokenize S5 underscore filtered. Now, if you look at the tokens, you will see that it has all the words. Now we have to find what are the unique words. So you can call this as unique tokens equals set of, you can say list of set of tokens. So unique tokens are like, snake, use, seen, programming, etc. Okay, store the result in a dictionary. So now create a dictionary called bag of words of S4 equals dictionary. So for every word or every token in unique underscore token, bag of words underscore S4 of the token equals, you know how to get the count of words, isn't it? So TOK dot count and T. Now print bag of words for S4. So now you can see like has one, there is one occurrence, snake 2, use is 1, scene 1, programming 1, zoo 1, Python there are 5 instances, easy there is 1, and language there is 1 number of words. So this is known as bag of words. Is the code clear to everyone? So first, split it, take the uniqueness, and then loop through the unique list, count it in the original list, and that will give you the number of occurrences of each word. Okay. So we'll take a break here. It's 10:30. Meet in 15 minutes and then continue with the next set of sessions. Okay, are you all back? Tejas, Yash, Ankita. Okay, let us start. So the next topic that we are going to start is lemmatization. So lemma means the meaning of a given word. Okay, what is the other word for that same? In Hindi, we would have used the word paryayavachi, isn't it? So for one word, what are the set of other words which mean the same? Okay, so that is called lemma. So for that, we have to use one library from NLTK. So from NLTK dot corpus import wordnet. Okay, now for which word I want to find out what are the other related words. So let's say I have a word called, let's say, language. So I want to find other words related to a given word. Okay, so here I have a word called language. I want to find what are the other words. So we use this function wordnet dot synsets. Okay, synsets. So now you can see here that the other words related to language are speech, lyric, linguistic process, language, and terminology. Okay, so you can store it in a result like this also. So sin of 0 will give you this. Sin of 1 will give you speech. Okay. Now to find what is the lemma. Okay. Now I will use the word, for example, I want to find out what are the other words related to language. So I can use, so sin of 0 is language. So here I can use dot. So lemma. So the other words are language, linguistic communication. So to get the lemma of a word, the input has to be in a wordnet format. That is why you have to use the synsets format. So similarly, I can use, what is the other word? It is speech. So what are the other words related to speech? So you can have communication, spoken language, voice communication, oral communication. Is this clear to everyone? Okay. So this is known as lemma. So after lemma, we have kya hai? Boss tagging. Okay, so we can also do word similarities here because they are in the same library. So similarity of words. So how two words are similar to each other or different from each other? So returns a similarity score between 0 and 1. So closer to 0 means not similar. Closer to 1 means similar. Okay. So let's start with the two words. Let's say the words are paper. And let's take a word, let's say car. Okay, I want to find out the similarities between these two words. Okay, so paper and car. Find the similarity between words paper and car. So first I will use wordnet.synsets paper. Now here I can see that there are different words related to paper. So one is the word paper, composition, newspaper, then wallpaper. So there are different variations. So which word I want to find a similarity? So let's take the first one, which is the word paper. The N that you see here means it's a noun. Okay. So let's say this word is paper. And then the second word is car. So I can use wordnet.synsets. And I use the word car. So here car, I have car, then cable car. So let's take the first one. And then I store the result in car like this. Now the similarity between these two. Okay, so our function is paper dot WUP underscore similarity and cut. So you can see that the value is lying in between 0 to 0.5. So that means these two terms are not related to each other. I can also do the other way, car dot WUP underscore similarity. So it returns the same number. So that means the two terms are not similar. Is this clear to everyone?
Yes, sir.
Now let us take one more example of cat. Maybe we can take cat and dog. So cat equals wordnet dot synsets and cat. Okay, now this is going to return. So let's take the first word. Dog equals wordnet dot synsets dog, and let's look at the list of things. So I have these options. So let's take this. Now let's do cat dot WUP underscore similarity and dog. So now see that this is returning a percentage which is closer to 1. So 85.7 or 0.857. So that means the two words are related to each other. That is, they are similar to some extent. Done? Okay. Now we'll go to the next section, which is called pause tagging. Pause stands for part of speech. So part of speech means that in a given sentence, what are the different elements of grammar that I have? That is nouns, pronouns, adjectives, adverbs, all these things. So that is known as parts of speech. So how many different types of parts of speech I have in a sentence? How do you identify them? That is what we are going to learn in this particular section. What is a noun? What do you mean by the term noun?
Unique.
Name of particular
हाँ बोलो.
name of the idea, place, person.
Correct. So noun means name of person, name of a thing, name of a place. What is the meaning of pronouns?
Phrase that contains noun.
Pronouns means something when you are referring to something which is going to replace a noun. For example, I, you, we, these are called pronouns. Okay. Then we have verbs. What do you mean by verb? Verb means action. Okay. Action words are known as verb. For example, walk, sit, stand, okay, sleep, eat. So wherever there is an action involved, that is known as verb. Then there is an adverb. So adverb is something that describes the verb. Okay. Walk slowly, sit quietly, stand. Okay. So these are adverbs. Then we have adjectives. What is an adjective? Something that describes the noun. Okay. Blue car, yellow scooter, black board. These are known as adjectives. Then we have conjunctions. Conjunctions means joining of sentences. So the words like with and, these are known as conjunctions. So how do you identify all these words in a given sentence? So that is called as the pause tagging or parts of speech. Now, how do you identify all these words? So in Python, in the corpus, we have a lot of abbreviations that tells you what those words are. For example, if I get an abbreviated string called CC, it means conjunction. If I get a abbreviation as N, it means noun. Okay. If I get, let's say, a number as FW, it means it's a foreign word. So I'll send you the complete list that what each of these abbreviations mean. Okay. So we have to get the nouns or the parts of speech based on these abbreviations. Okay. I'll show you an example. So first, let us create one sentence and see how we can extract all the different parts of speech from that given set of words. So let's take a sentence. What was the last word we had? Okay, let's S5. Okay, S5 is there. So let's take S6. Okay, so S6 equals. So let's write a sentence. The movie was a big hit. I sat through the entire 3 hours and had a good time. I also had popcorn and okay. So let's say that I am just putting some random sentence here. The movie was a big hit. I sat through the entire 3 hours and had a good time. I also had popcorn and bread. Now I want to extract all the parts of speech from this particular sentence. Now, generally, the rule is you always first have to do the removal of stop words. Okay, always in text analytics, remove stop words. So first get the tokens. So token equals NLTK dot word underscore tokenize of S6. So you have these tokens. And now you filter out all the stop words. So stop words, we can say filtered tokens equals for every token in tokens, if T not in stop words, then extract the word T. So now I have the filtered tokens. And now I can have the S6 underscore new equals dot join filtered tokens. So S6 underscore new. Okay, so this is my new sentence. Okay, now I need not form the sentence. I'm more interested in all the filters. So we can just leave it as it is. Now for each filtered token, find the POS tag. Okay, so I can write NLTK dot POS tag on the filtered tokens. Okay, so now you will see that I'm getting the POS tags. So print POS tags. So movie, it is giving the word as NN. NN means noun. J means adjectives. Hit is a noun. Sat is a verb. Entire is an adjective. 3, CD. CD means cardinal. That means it's a number. Okay, CD means it's a number, cardinal digit. Hours is a noun. Good, adjective. Time, noun. I, PRP. PRP means personal pronoun. Also is a RB. Okay, RB stands for adverbs. So popcorn is giving as verb. Ideally, it should have been a noun. Bread, it is a noun. So this is how you get the different parts of speech. Clear? Any questions or doubts in this from anyone? Okay. Now we have got all the different parts of speech tags. Now, suppose I want to extract only certain information. For example, extract only the nouns from the sentence. So how do you get only the nouns from the sentence? First, tell me what is the output? In which format is this output?
List.
It is in a list of dictionaries, right? Because I have a list and within that I have a, sorry, not dictionary, a tuple, a list of tuples. So I need to find out all the words which are nouns. So here I will write for word, comma, parts of speech in pause tags. Okay. And I also need to extract the nouns. So I can write nouns equals and put a list. Okay, now let us, I'll just print this value and see what are the return values. So you can see here W and P. So W is the word, P is the parts of speech. Now, what are the nouns here? So if P in. So what are the nouns? I have NN. So NN is singular, NNS is plural. So NN, NNS, and what else do we have? Only these two. So if the part of speech is either NN or NNS, then I'm going to do nouns.append W. So now I can write print nouns. And now you see the nouns are movie, hit, hours, time, and bread. Is this clear to everyone?
Yes.
So similarly, you can find what are the adjectives, what are the adverbs, what are the conjunctions, how many digits are there, all those things you can find out by using the same technique. Okay, so I'll send you the list, how to identify what are the different parts of speech tags. So there are some 10 to 15 different identifiers. So that completes the pause tagging. Then what else do we have? Pause tagging ke baad. Lemma is done, word similarity is done, pause tagging and n-grams. Okay. Next we have n-grams. I actually forgot to write one more topic here. Just make a note of it. This is called TF IDF. Term frequency inverse document frequency. Okay, so this is to determine the importance of a word in a given set of documents. Okay, so this will involve a little bit of calculations. I'll tell you those calculations and then we will see how to use this. Okay, so that will be the next one. So it's called TF and IDF, term frequency inverse document frequency. So now let us do n-grams. What are n-grams and how they are useful in text analysis? Now, n-grams means grouping of words in either a set of 1 or a set of 2 or a set of 3, and it can go on and on, 4, 5, 6, 7, 8. How many groups that you want, you can create that group. Okay. For example, if I have a sentence like this, when the cat is away, the mouse will play. Okay, let's say I have a sentence like this. Now, gramming means I'm grouping the words by selecting the value of n. So if I give the value of n as 1, I will get individual words. When, the, etc. till play. When I give the value of n as 2, it means it is going to group two words at a time. So I'll have when the the cat is away, etc. When I get the value of n as 3, it is going to group in 3. That is group of 3. So the first word will be when the cat. So when the cat is away. Okay, away the. Okay, like this, it is going to group into 3, and then 4, 5, 6, 7, etc., etc. You can form as many groups as possible. So this is called gramming. Now, is this concept clear to everyone? What do you mean by n-grams?
Yes.
Okay. Now the usage of this is especially when you want to find out specific strings in a given text. Okay, is not there and not there or there. Okay, so you want to find out whether a given sentiment is positive or negative, good or bad. You can use this concept of gramming to find out the correct sentiment of the sentence. Now, to do the gramming, the input data has to be in a text blob format. Binary large object. Okay, so it has to be in a text blob format. Input has to be in a text blob format. Now, I'm not sure if this library is there or not. So just try this from text blob, import text blob. Just check if this is working. If it is not working, then you may have to install one library. I'll tell you how to do it. Can you just try this? Working?
No, sir.
Okay. Okay, so do this. Go to the Anaconda prompt. Okay, Ankita says it is working. Okay. Yash, working? Okay, Yash has left, I think. Okay. Okay, Tejas, if it is not working, then you go to the Anaconda prompt. And here you type pip install.
So base root में ना?
Huh?
इसमें करना है?
Base, look here. Pip install minus capital U text blob. And then press enter. It will install the library. Pip space install space minus capital U, then space text blob. हो गया? हो रहा है?
नहीं, एक सेकंड टाइप कर रहा हूँ.
Is it installing?
Yes, sir.
Okay. It will take about a minute or so to get installed. Okay. Now form the sentence. So let me have a sentence. Okay, I'll use the same sentence. The movie was a big hit. I sat through the entire 3 hours. So we'll use the same sentence. So first, convert the input text to blob. Blob means binary large object. So S6 equals text blob of S6. And then S6 dot n-grams. So let me give the value of n equals 1. We'll see what happens. So you see that I have the word list, which has the sentence split into words of 1, set of 1. So we can say ng1. Now if I give n-grams to S6 dot n-grams of 2. So now you will see that it is organized the words into 2. So the movie was a big hit, etc. Let's try 3. So here you can see the movie was a big hit. So a big hit, if I have to look for these words, so this is a positive sentiment, a big hit. Clear? You can also try with 4. So sentence dot n-grams and 4. So the movie was a big hit. So it is grouping it into 4. Finished?
Yes.
So now we'll come to the last section of NLTK, and that is using TF IDF. Now, what is the concept of TF-IDF? Let me explain that, and then we'll write. There are libraries available, but we'll write a Python function to understand how it works. Very simple. Now, TF-IDF is used when you want to find the relevance of a word in a document and in a, I won't say group, in a set of documents. Okay, so when I say document, it doesn't mean that it's a Word document. It just means that I have a set of input text. Okay, it could be one line also, it could be multiple lines. So that is known as a document. So my document could be a sentence like India is my country. Document 2 could be India is a land of culture. Okay, so it can be a simple sentence also. So document 1, document 2 can again be a set of sentences, and document 3 can also be a set of sentences. Now let's assume that I have 3 documents like this, and I have to find out the importance of a word. Okay, so let's say that word is, you can say, let's say, machine. Okay, so I can find out the importance of the word given my input is all these 3 documents, but I have to also find out the importance of the word in each of these documents. Okay, so first what it will do, the term frequency will find out the importance of this word in this one. So if I give term frequency of the word in the given input document, so it will find machine in D1, the word machine in D2, and then it will find the importance of the word machine in D3. So this will give me some number. So let's say the number is N1. This will give me a number N2, and then this will give me a number N3. So I'm getting 3 different results based on the importance of the word in each of these documents. So this is called term frequency. Importance of this term in each of these documents. Is this clear?
So repeat again.
I have a document called D1. I have a document called D2. I have a document called D3. I want to find out the importance of a given word in each of these 3 documents. Okay, how relevant is this word, or how important is this word in each of the documents? That is given by the term frequency, or TF. Clear?
Yes.
So suppose in my D1, I have a sentence, the machine is old. My second sentence, there are no jobs here. Now my third sentence is, machine is fast. Machine is new. So here I can see that the occurrence of the word machine is 1. In this, the occurrence of machine is 0. And in this sentence, the occurrence of the word machine is 2. So it is going to find how many occurrences are there of this word. So number of occurrences divided by total words. So how many total words are there? 1, 2, 3, 4. Out of which, how many occurrences of the word machine is there? 1. So the relevance is 25% in the first sentence. Is this clear?
Yes.
Then we have IDF. So IDF means what is the relevance of the word in a specific document and in a specific document. Okay, just give me 5 minutes, please. I'll just be back. Sorry, I just had to attend that call. Okay, so TF, the relevance of a word in a given document. IDF is relevant of a word in a document with respect to all the documents. So what is the net effect of the word that is given as? So the net relevance is given as term frequency multiplied by inverse document frequency. So TF multiplied by IDF. So how do you find the IDF value? So I'll give you the formula for that. So IDF formula is, what is the total number of documents that I have? Okay, so total number of documents, let's say I have n documents, divided by the word count . Okay, word count of each of the document. So if I have 3 documents, what is the word count of this word machine in each of these? So that is going to be the word count, and that is the IDF. Now, what is the net relevance? TF multiplied by IDF. Is this clear to everyone? Hello? Hello? Is the formula clear? Hello, Ankita, are you there?
Yes, sir.
Okay, so this is the formula for the IDF. Now, because I'm taking all the documents into consideration, now if you look at the second document, the word machine is not there. So the denominator will become 0. So I cannot divide any number with a 0. So the word has to be a positive one. Okay. So this entire IDF, I have to take a log of it. So I'll take log of n upon word count. Okay, that is the formula for IDF. So let's do this in Python and see how to find the relevance of a word using TF and IDF. Relevance of a word in a given set of documents. So I'm going to write 3 functions. One is to find out what is the TF, that is term frequency. And the next one is called inverse document frequency. So term frequency is to find the relevance of a word in a document. Relevance of a word in a document. So my input is going to be what is the word and what is the document. Clear? So the formula I told you was the word count divided by total words in document. So first let us see how many total words are there. So tokens equals NLTK dot word underscore tokenize and the document. So this will give me the tokens. So total words equals length of tokens. So this is going to be the denominator. Next, what is the numerator? Word count equals, in this document, count the number of occurrences of the word. So this becomes the numerator. Okay, and now return numerator upon denominator, which is word count divided by total words. So this is the term frequency. Is the logic clear? Okay. So now let us run this and see with a small example. So let's say that I have a document called D1. So D1 equals, so let's say analysis is the new trend. Analysis can be done in multiple ways. Okay, let's say I have a document like this. Now I want to call the function term frequency, where the word is analysis and the document is D1. So let us find the relevance. So it says the relevance is 15%. So that means 2 divided by the total number of words that I have in D1. Now, if I have one more document Now, if I find out what is the relevance of the word analysis in D2, you will find that it is going to return zero. Okay, because analysis is not there in the second document D2. Is this clear? Okay, now let's find out how to calculate the inverse document frequency. So inverse document frequency. So inverse document frequency is to find out the relevance of a word in a given set of documents. So here my input is going to be, what is the word for which I want to find out the frequency, the importance. And then I have a list of documents. Now, because this function contains a log, so I'm going to import. So from math, import log. So you can write here, IDF uses the log function to calculate the relevance. Okay, so first is, what is the document count? So document count is going to be length of list of documents. So this is going to be the numerator. Then word count. So I'm going to initialize a value 0, and this is going to be the denominator. Now for every document in list of documents. Okay, so for every document in the list of documents, so I have the first document. So here I will check if the word is present. Increment word count by 1 if present. So I will write if d.count of the word is greater than 0. That means the word is present in that document. I'm going to increment the word count by 1. Is this formula clear?
Yes, sir.
Now, is this mandatory that every document should have the given word? Is it compulsory that every document will have that word which I have specified?
No.
No. Okay, so there can be an instance where the word count can return 0, isn't it? So to prevent that error, so there can be instances when word count can be 0. So now I cannot afford to have a 0 in the denominator because it is going to return a calculation error. So I will check. So if the word count is 0, then increment that by 1. And then return document count divided by word count. Okay, and then I have to do a log of this. Now, let me check the value. Now, I already have the two texts, D1, D2. So let me put one more here. D3 equals Tableau used in analysis. SQL is a good choice for analysis. D4 equals lots of opportunities in analysis area. Okay, so let's say I have 4 documents where 3 documents contain the word analysis and there is 1 sentence that does not contain the word analysis. Now find out what is the IDF for this. So IDF. So first I need to find out the list of documents. So list of documents equals D1, D2, D3, and D4. Now find out the IDF. So IDF is word and then list of doc. And now you will see that it is returning the relevance as 1.38. Okay, so now I will combine both these. So TF IDF is a combination of TF and IDF. So def, TF, IDF, Word, document, and list of documents. So return TF multiplied by IDF. So TF takes two parameters, which is Word and doc, and IDF takes the two parameters Word and list of doc. Is this clear?
Yes, sir.
Okay, now find out the relevance. So TF, IDF, the word is analysis. In which document I want to find? D1, and then list of doc. So this is 0. Then D2. D3. D4. So everything is returning 0. So that means the relevance of this word is almost similar in each of these documents. So if I change this slightly, and now see if it is going to make any difference. So here you can see that the word is returning a value of 0. So that means equal importance to this word. Okay, so that wraps up the NLTK basics. So from next week, we will do text classification using NLTK and how we can do sentiment analysis. And that will be the end of your course. Ankita, can you come to the class next week if it is possible for you?
Actually, so Saturday I'm on working, so that's why on Saturday. Sunday I'll come. Sure.
Okay, next Sunday, na? Okay, because we are planning to also have a kind of doubt clearing session because this is going to be the last class. Hopefully by next week, we should be able to wrap up.
Okay.
That is for, I won't be there after that. So if you have anything, do you want to have any QA session, something like that? So maybe you can come in to the class next week.
Okay, sir.
So any questions, any doubts in today's session?
No, sir.
Okay. Okay, so I won't start anything new. Next week we will do the text classification. Okay.
Yes.
Fine then. So thanks and see you next week then. Okay. Bye.
Thank you.